Hello, so we are back and this time we have a nice laptop to repair. So check here. This is 17-inch. i7, Iris graphics, like a proper nice laptop. Now what's the problem with this laptop? We have a letter from Simon. And Simon said he checked the motherboard. He found like a power rail fluctuating from 2.5 to 3.5 volts, but he checked with a chip multimeter. But I really doubt, even a chip multimeter, it will do the job. I have not attempted desoldering the components, and the previous owner reported turns off and once turn on and then off again. He believed the previous owner swapped the SSD, so it's no SSD inside. I didn't open the laptop, but Simon wanted to fix the laptop. So we can fix the laptop and do a video on the same time? What do you think? Simon looks like a nice guy. So I will say, let's plug a charger and see what this laptop is doing, right? What charger do you need? Oh, it's blue pin. HP blue pin. So plug in the charger, HP blue pin. No, sorry, this is Acer. My fault. So plug in the charger. Nothing. Nothing. There should be like 10 milliamps. This looks dead. Pressing the power button, this is the power button, and it's not seeing the power button. Check there, like zero current, nothing, dead. So I'll say let's open the laptop quickly. Okay, so the back cover is removed. It's looking nice inside. So what we are checking first? What is here? Oh, things, yeah. I have some things here. This is like brand new. Okay, let's take the multimeter and let's check few things, yeah, like basic. Before we are checking the main power rail, hopefully you can see or you can spot the problem. Let's check the charging port, and at the charging port we have 19 volts. Okay, the main power rail, you can see the coil, duct, yeah, whatever is this black thingy, like cheap Mosfet. Then you have capacitors, and here you have 0, and here you have 3 volts. Mosfets, coil, capacitors, 3 volts. So you see the main power rail has 3 volts. So what do you think about this? Why the main power rail has 3 volts? Because it's shorted. No, if it will be shorted, it will be nothing, yeah? So I believe what the problem we have here is, one second, and without the charger we have 1.3 volts. The problem here is the input circuit, yeah? So let's remove the battery, and I can't see here the first two MOSFETs. So I believe we have to, no, are not here, right? No. Yeah, wait a second. Why this coil has 4 MOSFETs? Huh? Remember, recognizing parts of the circuit is very important, yeah? So the question is, the logical question you have to ask yourself, why that coil has 4 MOSFETs? Because can be a dedicated power supply for the main power rail, yeah? And it is. That's the only reason why this coil has 4 MOSFETs. So let's check. So the input, I'm assuming, is here. Or maybe not. It's not here, then it's here. No, it's not here. Then it's here. No, it's not here. This is the current sensor. Yeah, one second. Then we have two MOSFETs. Check here, yeah? So probably the main power rail is coming here. Check on the screen. 19. So the charging port track is coming straight here. Then we have the first MOSFET. And after the first MOSFET, we have 19, yeah? 19.5. 19.5 is good. Then we have the second MOSFET, yeah? So the output of the second MOSFET, we have 19.4. Lol. But we checked here and there was no voltage. It is 19.4. Okay, so you see exactly what I told you. Here we have 19 volts, you can see. But this coil, at the output of this power supply, we have 3.4. So this coil is not switching. This circuit is not working. So who's driving this power supply with 4 MOSFETs? This little prick. Trust me, this is a prick. So let's see. We have a diode, resistor, capacitor, right? So here we should have, and we do have 19 volts. Okay, we do have 19. If we have 19, the chip is dead, right? Can be. You know what? Probably I will spend another 10-15 minutes and I will come back to the same point, actually replacing that chip, because probably it's dead. So what I'm gonna do now, I'm gonna... Fuses, where are those fuses? Check here. Fuse, who cares? No one cares, it's taking no current, nothing, okay? So let's come with the power supply. Let's come with the power supply and let's see what it's doing. We have like 3 volts there. Let's try with 4 volts then. Let's try with low current. Let's lower the current. Yeah. And let's see what is happening. So here and here, right? And it's short. Okay, no, here and here. And it's taking 110 milliamps. This current can be taken by the battery, yeah? So let me disconnect the battery just to be sure. And you'll say, sorry, yeah, but 110 is not that much. Yeah, it's not, but we try with 4 volts. What about if we're coming with 12 volts, huh? Yeah, you're right, we don't know what voltage has the main power rail, but I can tell you. So based on the battery, so the battery has 15.12. That means the main power rail is around 15 volts. So with 15 volts, it will be a different story, you don't think? So let's disconnect the battery. Yeah, now it's fine. And let's come again with the power supply. Here. And it's taking nothing. No, 100 milliamps, check that. So I want to know what is taking 100 milliamps. It's very important to find out what is taking 100 milliamps. Because whatever is taking 100 milliamps, very possible to be dead. Lol, no button. So here is the EC chip is here. So let's see. Let's see if we can help Simon. Because Simon says we have to help him. So here, no, here. Here, 100. But it's going to 0. This is a power supply. It's actually a power supply which is switching. This is not like a dead short. So check here, yeah? 10, 0. You see, it's a power supply which is switching. Wait, I seen something. Something is there. So that's the EC chip there? Huh? The EC chip is dead, you think? Okay, that's bad. That's very bad. Let's try something else, yeah? Let's come with the voltage here. And let's raise the voltage. Nah, the current is going down, you see? So the current is going down. Check there. 14 volts and the current goes down. No, it's nothing faulty. I mean, whatever is taking like 20 milliamps is behind of a switching power supply, yeah? And obviously, that's how a switching power supply is working. You lower the voltage, and the power supply, it will increase the current in order to keep up with the output, which is not happening here. Yeah, it's doing it now. You can see 110 milliamps. If I raise the voltage, you see the current is going down. That's how the power supply are working. So we know it's not short. I mean, yeah, it's not short. No, it's not short. No, we know it's not short. To say like, okay, sorry, and this power supply is not outputting voltage because something is short. No, it's not short. But still, this power supply is not working. And the only reason can be that little trick which I told you. Let's check the coils just to be sure, you know, the coils are good. So this one is fine. This one is fine. This one, yeah, it is working. The other one is fine. Here you have a bunch of coils. Yeah, 26 on CPU, that's fine. What is this chipset? 100 ohms, everything is fine. So it's no issue here. So the issue is here with that chip. Yeah, it's nothing what we can do. Just to replace that IC. I mean, what do you want me to do? Huh? Sorry, pull up the schematic now. It's pointless, you know. What do you think it is? Like a resistor, a capacitor, or huh? That's what you think it is? I mean, just think, yeah, you have few components like capacitors, resistors, and IC. Which one has the highest probability to get burned? Huh? Okay, the problem is I don't have this chip. So what I'm gonna do, I'm gonna order the chip, and I'll see you on the next one, right? Bye. So we are a few days later, and I got the chip. Actually, ordered two. So let's order the chip quickly, and let's see if it's working. I don't really remember why I diagnosed like being at that chip. It was a few days ago, but you know, I trust my judgment. Like usual, the hardest part is to admit when you are wrong. Okay, so first let's desolder the original chip. I will use a little bit of rosin flux. Just a little bit. Hot air, 180. Chip position. Good, so the chip is out. Yeah, that's the chip position. Now the new chip, we should try to resolder from before, right? Yeah. Let's see if the chip is getting soldered nicely. We have a little bit of rosin here. Yeah, it is. Yeah, no problem then. Yeah. Good, let's solder the chip. The chip position. It's still moving. Good. Perfect. Perfect. So the chip is moving, that means it's soldered properly. Okay, let's cool down the board. And hopefully it will work. Yeah, the board is fine. Plug in the battery. Let me plug the charger. Plug in the charger and it's taking 100 milliamps. I don't know what was doing before. Huh? Was doing the same? But basically it's not charging. This is a bad sign. I mean, why is it not charging? Let me try to power on. Pressing the power button, and no, it's not working. Ha ha. It's not working. Okay, let's check the main power rail. Now this is crazy. We ordered that chip for nothing. The main power rail is 4 volts. I think it's the same like how it was before, right? We ordered the chip for nothing. I can't believe. Oh, this feels bad. I mean, it feels like, I'm getting old. Plug in the laptop without the battery and nothing happened. Okay, let's check one more time. The main power rail is 3.9 volts. Unplugging, plugging back, 3.9 volts. Whatever I do, I have 3.9 volts here. So what is the main power rail? 15 volts. Yeah, let's see, 15. We have a short or what? One second. No, it's not short. It's not short, check that. We have 16 volts and it's taking like 40 milliamps. So it's not short. The keyboard? Yeah, we can remove the keyboard. It's doing exactly the same. I think I'm getting old. Okay, let's check the 3.3 to see if it's present. That's the keyboard connector. And the 3.3 is not present. So why I replaced that chip? Why didn't focus on the EC chip? So the EC chip is here. That's the EC chip, Novoton. So the 3.3 it is present. 2.9 volts. Three volts. Looks like we have 3 volts on this chip. 3 volts. But why we don't have voltage on the keyboard connector? I mean, we should have the power. We should have the power button voltage, right? We have 3 volts. Check that. We do have 3 volts on the keyboard connector. On the BIOS, we have nothing. Oh, sorry. Yeah, nothing on the BIOS. So let me get this straight, yeah? Basically, we replaced this chip for nothing, right? Here we have 0. Here we have 0. Here you have 19 volts. 9538H. Let me find the schematic. You know what? I remember this chip. I remember this one. You remember on one pin from here we should have 5 volts. You remember? We have like a like same like a HP laptop. And we did have a problem with VDD pin or VDDP. VDD and VDDP. So VDD internal LOD output. And VDDP, where is it? Here. Okay. So I want to know if this VDD pin we have 5 volts. Pin number 18. Yeah, that's the one. Okay, let's see. Here. So here we should have 5 volts and we don't have 5 volts. Check here. You can see no 5 volts. We don't have 5 volts. We have 2.7 now. Now we should have 5 volts there. Let's go with the power supply. Yeah. 5 volts here. And it's taking nothing. So it's not short. Plug in the charger and now it's shorted. I short the chip, right? I blow up the chip. I can't believe I burned the chip. Let's see. Yeah, check there the Mosfets. So plug in the power. You can see. I burned the chip. It's my fault. Feels bad, man. Not only it's not working, but already I burned the chip. Yeah, feels bad. When I checked, yeah, with the multimeter, I think I made sure between 19 and 5 volts. That's how I burned the pin. The chip. Okay, we remove the chip. Let's come with the other new chip. That was a good idea. I bought 2 chips. I knew. I knew bad things can happen. I knew it. Yeah, we need a little bit of flux. You're right. Brush in. Perfect. Yeah, I seen that. Yeah, I seen it. Perfect. Now let's cool down the board. Okay, let's see now. Plug in the charger. Plug in the charger, and it's short. I think I short the Mosfets. Oh, I'm like a beginner, I can't believe. I'm like a freaking beginner. So what happened? What happened here? What happened here? We short those Mosfets. This one has 5 ohms, and this one has 5 ohms. Yeah. And of course, between the minus and plus, we have 8 ohms. Yeah, we short the Mosfets. Let's remove the Mosfets. So many mistakes in one video. I mean, those are solid Mosfets. I don't understand how I could burn them. Yeah. Doesn't matter. So this is one. Good. And this is a second. Perfect. So replace the MOSFETs. Let me cool down the board. Can be even the other two MOSFETs burned? Can be. Can be. Don't tell me, but probably not. Let me check the other two MOSFETs. Good. Good. The other two are good. So let me plug the charger. Plug in the charger. 20 milliamps. 30. It's a good start. It's a good start. 30 milliamps. At least it's taking something. Let's check the voltage. Nah, he's gone. Yeah, he's gone. He's gone. And what we have left is 17.5. Huh? We didn't have voltage before. The main power rail was like 4 volts, you remember? Yeah, let's plug the battery. Plug in the battery. Plug in the charger. Taking like 30. We have the charging light there. Check that. Charging light. 17.5. Now, one question is why 17? Because the battery is 15. And the second question is what is taking 20 milliamps? Let's check this chip, 5 volts internal LDO. So 5 volts internal LDO, check on the screen, it's 5.1, you can see. So actually this chip is working. Now let's press the power button. And it's not coming on. No, nothing, dead. I believe we have two issues here. We have the white light here. Disconnecting the battery, no change. Yeah, so this battery is not charging. It has voltage, but it's not charging. So that's a different issue. They check there 17.4. No, it's not charging. I want to know what is taking 20 milliamps. Yeah, that's what I want to know. So I'll let the board to cool down, and then I can check with the thermal camera to see what is taking 20 milliamps. Wait a second, I just realized we test the laptop, but the keyboard is unplugged. So obviously if the keyboard is unplugged, the power button, it will not work. No? Let's plug the charger. Plug in the charger. Pressing the power button. And his laptop is coming on. Check that, we have light on the power button, but it's not taking power. It is taking one. Wait, goes off. Yeah, the laptop just switched off. Pressing the power button, it is coming on. You can see the light there. 600 milliamps and it's going to 0. So it's still a step forward, you don't think? Let's check the voltage. Let's see why the laptop is going off. Because the voltage is going out. So power button here. Voltage here, 3.2 volts. That's sick. Pressing the power button. Nothing happened. Wait a second. It was 17 volts. We checked together. I can't believe. It's not coming on anymore. That's crazy. We checked together. We checked together. Together. Now we have the charging light. We have 17 volts. Okay, that's good. I'm pressing random buttons here. Hopefully I will get the power button, but no. No, it is on. It's on. It's on, goes to 270 milliamps and it's going to 0 because the voltage is dropping. Check that, 4 volts. Plug in the charger and you have 17 volts, right? Pressing the power button. Soon as the current is going up, the voltage is going down. You seen that? You seen it? Okay, let's disconnect the battery. So we disconnect the battery. Plug in the charger, we have 17. Pressing the power button. The current is going up, the voltage is going down. This is a tricky fault. This is a tricky one. Now, why the situation change? I mean, yeah, we replaced one more chip and we replaced 2 Mosfets. Why the things changed? So we replaced 2 Mosfets. But what about the other 2 Mosfets? Do you really think even the other 2 Mosfets are like dead? This one is good. This one is good. Good. This one, check here, check here. Yeah, so this is gate with source. and we have 0 ohms. You can see on the screen, we have 0 ohms. So the MOSFET is dead. This one is dead. The other one is good, but this one is dead. So this one is gone. But you see the interesting part? So actually it was not shorted drain with source, how you expect. That's how you expect, because the gate is capacitive. No, it was gate with source. Okay, let's solder the MOSFET back. Perfect, so the MOSFET is soldered. Let's test. But it's looking good. I mean, the EC chip is responding when I press the power button. It's looking good. It's really looking only like a power issue. Let's plug the charger. Plug in the charger. Good. Let's press the power button. Pressing the power button. Holding the current. Check there, 1 amp. Check there, 1 amp. 1 amp. Come on, give me picture. Give me picture. This was a hard job already. Give me picture. Come on. All I want is picture. We have picture! That's crazy! We fix it! I can't believe! I can't believe! So even if you ask me, sorry, what was the problem? I can't tell you. Yeah, it's working fine. Lol. Let's see the charging, yeah? So the charging. Plug in the battery. Oh, the battery is dead. This battery is dead. We have the charging light here, you can see, but it's not charging. 17.1. Plug in the battery, and we have 17.4. The battery is locked. So you see, with 17.4, the battery should take a lot of current, which is it's not taking current. Look now, it's 15.6. Yeah. So that means the battery is still speaking with the EC chip. That's the reason we have the drop from 17 to 15. Yeah, it's not because the battery is taking current and the voltage is getting dropped. No, the battery is taking no current. It's because the EC chip is speaking with the battery, but the battery it is locked. Yeah. It's nothing what we can do. I mean, even if I come with the power supply, let's come with the power supply. Let's lower the current. I'm pretty sure it will not charge. Yeah, like 1 point something amps. So check here, yeah? So we have ground. And here we have plus, yeah? And it's taking what? 10 milliamps. Check there. You can see on the screen. And my question is, can we go the extra mile and actually help this customer with the battery? But how we can do it? Where is the board? Let's do a small incision, yeah? Surgical. Okay, so here are the cells. This is not helpful. Because if I charge one cell, the battery will get locked, yeah? Because the cells, it will be unbalanced. Now here is the board. You can see the board? There is the board. Then now I have to find the minus and plus. And here it's a plastic thingy. You can see it? Yeah. Okay, so this is coming out. Another incision here. Perfect. Perfect. Okay, so we have the board here. That's fantastic. And that means the other board is here, right? Yeah. Yeah. So we do have the other board here. So what we are looking right now we're looking for the highest voltage possible. That's what you are looking when you open the battery. So you try to find two pins with the highest voltage possible. So from here to here we have 3.4. From here to here we have 5.2. From here to here we have 7 volts. So at the moment 7 volts is the highest voltage. Yeah. From here to here we have 3, 5. Okay, so the highest voltage, it was here, yeah? So the plus is on this side, right? Yeah. Plus is here, minus is there. Let's charge the battery. It's charging now, check there. It's taking 500 milliamps and the voltage is rising quickly. We have 10 volts, so let's raise the current. Let's raise the voltage. Yeah, 1.5 amps, and we have 12 volts and it's going up. 12.3, 12.4. Good, let's raise the current. Yeah, 2.4 amps, we have 13 volts. So if we stop now, do you think the battery will charge? Oh, what do you think? 13.8 volts. Yeah, let's see. Let's see if it's charging. So plug in the battery. We have 20 volts on the power supply. We have the charger here. Plug in the charger. It's taking 30 milliamps. It's not charging. Because we do have voltage on the battery connector. You see, we have like 15, 16 volts. But the battery it is locked. No, the battery is taking absolutely no current. Nothing. We do have the charging sign here, but it's not charging. Let's get the NLBA, yeah? And try to analyze this battery and see what is wrong with this battery, yeah? I mean, don't get me wrong, this is not our job. We are not paid to fix the battery. I mean, I can easily tell the customer, you need another battery, and it will be no problems, no issue, yeah? But, you know, if we can help, let's help. Okay, NLBA, and it's on the screen. Start reading, and let's find the clock and data, right? How can I do it so you can see what I'm doing? Like that, yeah? Good. So how we are finding the clock and data? Randomly, you know, just connecting the wires. Nothing. Let me power on. Yeah. Let's push some, you know, current into the battery. Nothing. Okay, check there, check there, check there, check there, check there. Yeah? So we are able to read the battery, and the cells are balanced, but the battery is locked. Charging current 0, charging voltage 0, read the capacity, it's empty. Check on the battery health. That's all that I'm saying. Because people say, sorry, that battery is a dead battery. This is brand new. You can see brand new with the cycle count of 17. You can see 17 cycles. This is brand new. So why this battery is locked? Let me try a trick. Yeah, it's locked. The battery is locked. Good. Stop reading. Power off. Yeah, even without the power, it's still reading the data. Good. Let's try to unlock the battery, yeah? Please save the original EEPROM first. So you can see it's saying sealed, charging disabled, discharging disabled, and PF status 1. Let's read the EEPROM. Error while reading. Okay, unseal. Read chip info. Clear chip errors. Error clears. Read chip info. And now we have PF status 000. So seal, exit boot, and now we are going to the battery info. Check there, yeah? Battery unlocked, you can see. So now if I go now to charge, start charging, check there, check the current, The battery is taking current because we just unlocked the battery. Beautiful, and check here, the current is rising. And this is a brand new battery, you understand? How the battery died? Probably the laptop was dead for a long time, the battery discharged, and when the battery is getting over discharge, it will get locked in self, even if the cells are good. Okay, so we can clearly see it's charging. So what I'm gonna do, I'm gonna stop charging. Yeah, unlocked, we have some voltage on the cells. Yeah, a little bit of capacity is fine. So now let's disconnect the battery from the device. And let's bring the laptop back. Bringing the laptop back, plug in the battery. Yeah, like that. Let me get the blue pin back. 1 second. It's taking 200 milliamps, the battery. And the voltage onto the battery is 13.1. Now the battery is taking current. The current is a little bit too low. Here we have 15 volts. Wait, here we have 15, but after the Mosfet, we have 15. Yeah, and the battery is taking 3 amps. Check that. Huh? So right now the battery is charging with 3 amps. We fixed it! I can't believe. Yeah, we fixed even the battery. Yeah, the battery was tricky. 3.2 amps, only the battery. Check that. It's working great. But the battery, it was locked, you remember? Now, if you're looking for the NLBA device, for a new viewer, I will leave a link on the description about from where you can buy the device, yeah? And if you use electronic repair school, the coupon, you get like $10 discount. Okay, so I'm gonna stop now. We helped the customer. We went the extra mile, which compensate with the sloppy work we done it on the beginning. Yeah. So I will say thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.